Hi students, this is Oxide Design. Today's our topic is basic fabrication steps presented by Subhash Devi. This basic fabrication steps completion of this topic, students will be able to what are the basic fabrication steps followed in the CMOS and explain the different steps involved in LML CMOS fabrication process with neat diagrams. The fabrication sequence consists of a series of steps in which layers of the chip are defined through a process called the photolithography. Here we are having basic fabrication steps are first one wafer processing, mask making, photolithography, oxidation, diffusion, etching, polygate formation and metallization. The basic fabrication steps, first of all, in the wafer processing, the single crystal wafer diameter is 70 mm to 200 mm thickness, less than 1 mm, front face polished, scratch-free mirror finish. Nearly see in the diagram, you are clearly know about the fabrication steps. Next one, mask making. In the mask making, after completing design, the drawing is broken into subsequent IC processing steps. These steps are called mask levels. Electron beam machine, known as pattern generator, is used for mask making. The interface is CIF between layout and mask machine. Mask machine transfers design features directly on photosensitive glass plate using the CIF. Basic fabrication steps. It's a photolithographic. The process used to transfer a pattern of wafer is called lithography. The process has 6 steps. That steps are N-will, polysilicon, N plus diffusion, P plus diffusion, contacts and metals. First one we are having the photoresist coating and pre-packing. Photoresist coating. Third one is fabrication process is the alignment and exposing. Here we know that diagram we are having clearly explained the ultraviolet radiation is applied to the top of the portion and photomask is produced in the top layer of the metal oxide semiconductor. Then development and post packing, it is that ultraviolet rays edging that place is known as handed photoresist. That place is clearly make that diagram in the session. Then etching and removal of photoresist, that etching and removal, that etched place is removed, already known that plasma glow discharge is shown here and then photoresist is applied and then that etching place is removed from the area. The diagram clearly show, that's why you are understand the from the diagram itself. Then wafer, after removal the photoresist, we are applying the wafer module to the removal of photoresist place. Then basic fabrication steps followed here. First of all, oxidation. The purpose of silicon dioxide layer is acts as a component of metal oxide semiconductor. That silicon dioxide is a one layer of metal oxide semiconductor. It's an important layer. Then acts as marks against diffusion used to isolate the devices and provides electrical isolations in multi-level metallization. Several techniques include in these fabrication steps that are in the silicon dioxide layer. We are having some techniques that are thermal oxidation, wet oxidation, CVD and plasma oxidation. Diffusion. The purpose is to alter the type of conductivity by diffusing the impurities. Impurities means adding the impurities in the pure materials, that is called impurities coal, where the control of impurity concentration, uniformity, reproductivity. Then two techniques are used: furnace diffusion and ion implantation. Then metallization is done to provide low resistance interconnects. Common method is evaporating and sputtering. In high vacuum chamber, the metal is deposited by evaporation with subsequent condensation on substrate target. Then basic NMOS fabrication steps: formation of silicon dioxide and then photoresist coating. Here we are having the three types of layers. Here this is the N-type silicon and the basic one silicon dioxide layer, that means SiO2 layer. Then here we are having the P-type silicon epitaxy layer. Then photo mask and then etching of selected area. Here only we are having this process. Under this process we are having the terminals, gate, drain and source. Like that we are going to make the terminals. Photo mask is applied here, and then gate oxide is applied in that layer. The wafer is then placed into an oxidation furnace and thin oxide, the gate oxide, is ground to cover the etching region. Next, polycrystalline silicon is placed here. The layer of polycrystalline silicon is deposited all over the wafer. This layer is then patterned and etched to form the gate of transistor. This is the acting as the gate terminal of the transistor. The N-type dopant is introduced into the opened region and diffused into the wafers. It is classify the three terminals. First one is the source, and then here it's a gate. It's acting as a gate here, source, and then this is the drain. Here N dopant is introduced here. Next, oxide is deposited using low pressure chemical wafer deposition and is used for top coat production. Here we are having some coating materials and the production coating is applied here. Basic NMOS fabrication steps. Next, the layer of aluminum is deposited all over the wafer and patterned and etched to form the interconnecting layer and the connections to channel metal oxide semiconductors. Here we are having the aluminum. The blue indicate the aluminum coating of the layers. Then fabrication steps is shown here: physical structure and then N plus, then nitride oxide and then P substrate, then photoresist. Like that we are almost done in that all the process in the CMOS fabrication steps. That fabrication steps, that red indicate the polysilicon and plus it's a color coating of the MOS transistor. Then fabrication steps, what are the contact material means black indication, it's a metal contact. Like that we are indicate the color coating of the metal oxide semiconductor. Then after that, the quiz question of the fabrication step: draw the cross section while manufacturing the diffusion.